Okay. Good morning, good afternoon, and good evening, maybe. It's great to see so many people joining us. If you wouldn't mind just popping into the chat where you're joining us from, you can pop in there your city or country, or if you'd like to pop in your company name.
Fes-ho tu, Xavi, que no sé ben bé.
We've got Sweden, USA, Germany. Serbia, Netherlands, Cram. Hi, Jason. Can everybody see the chat okay? If you, I don't know what I'm going to do if you can't. Okay. We're just admitting the last few people now. And I just want to remind everybody that this webinar is being recorded. So as I said, welcome to this afternoon's webinar, How Hydraulic Testing Can Save You Money, presented by Martin Cuthbert. My name is Emma. I'm the Sales Office Manager for UK and ROW. Today's webinar is one in a series planned for this year, so keep your eye out for further details on our LinkedIn page. And there will be an email following this webinar landing in your inbox tomorrow, full of useful information. We've disabled cameras to save on bandwidth, but your mics are currently muted, but you are able to unmute yourself should you need to. For questions, could you pop your questions into the chat function, and we'll endeavour to answer questions during the presentation if we can, or at the end. I'm going to hand over to Martin now.
Okay, thank you very much, Emma. Welcome everybody. It's great to see so many people attending today and from all around the world. So it's quite exciting to see all the different cities and countries that appear in the chat. Webtec's vision is built on improving the performance of hydraulic machinery worldwide, and this webinar is very much in that theme. We've been running public webinars for the past year or so. I'd like to say a particular thank you to Steve Skinner, whose many decades of experience in fluid power training have helped us produce these webinars, and this is absolutely a team effort. So thank you, Emma, for facilitating, and Sam for helping a lot with the presentation. Just to reiterate what Emma said, there is a recording going out of this presentation, so you shouldn't need to make too many notes. There will be a recording to watch afterwards, as well as other resources that we'll be talking about on the way through this presentation. So rather than bombarding you with facts, we found it's more fun to talk about hydraulic testing through the eyes of a user. So I hope you like this style. And as Emma's already mentioned, feel free to ask questions in the chat on the way through. So we're going to start by talking about mining and oil field services. As the name suggests, this is a full service company supplying these two industries. It has a large fleet of mobile and industrial machinery. And if you've been on these webinars before, you may recognise their name. Just for the record, this is a fictitious company, and so are the people, but they are based on many of the companies and customers that we've dealt with in the past. And their mission, their mission is always to create a safe working environment, be a reliable supplier of choice, and provide innovative solutions. So that's the backdrop that they're working against. And so we should introduce two main characters, if you like, in this business. The first is Lauren, who's the CEO of the business, and very experienced CEO, renowned for being tough but fair. And he's a team of managers working for him, the newest of which is Steve, the service manager. And the challenge they have is that their fleet of machinery is getting quite old and unreliable and keeps breaking down. An example there of a crushing machine they have, which is unfortunately stopped. And Lauren doesn't want to invest more money in lots of new machinery, but he really wants to sweat their existing assets. He also wants to fulfill their mission of being a safe, reliable and innovative supplier of choice. But he's also aware that their reputation's in danger as machinery keeps breaking down at the most awkward times and jobs are taking much too long. So Lauren's employed Steve and given him 6 months to turn the situation around. So Steve's been thinking about how he's going to increase machinery uptime and save their reputation, and he's identified 3 key challenges really. First of all, that his team is relatively inexperienced. They don't actually have a structured maintenance program across the business, and that their operating costs are way too high. And he understands really it's no wonder that Lauren doesn't want to buy any new machinery, because as it stands at the moment, they're not really utilising their assets the way they should be. And that's a real danger to their reputation of being a safe and reliable supplier. So how can Webtec help? So for over 60 years, we've been helping mobile and industrial machinery OEMs. We're manufacturers of hydraulic measurement and control products, and we've listened to feedback from users and OEMs over many years, and our aim is to improve the performance of heavy machinery. And we look across the applications that we've dealt with and supported. The applications vary enormously. We've got examples there of forestry, of agricultural, of demolition, of construction. But overall, we've seen that there's a 3-step approach that works in pretty much all of those situations. And that's what we're sharing here with Steve as to how he can deal with these challenges. So Steve's there going, how can I keep machines running longer and keep costs under control? So how can he help with his inexperienced team? And the first step there is looking at competence-based training. And while Webtec isn't a training school, and we don't pretend to be, that's our expertise, we have had a lot of relationships with different training organizations around the world. And so there's various resources that you can go to and places you can turn to. So if we look on the left there, there's a book that with Steve Skinner's help, we published on practical hydraulic system maintenance. That book is available on Amazon and supports various initiatives around STEM. That's just an example of some of the material that's available out there. In terms of authorized training courses, then we would turn to the industry associations like CTOP, like the NFPA for America, like the BFPA for Britain, or the IFP, the International Fluid Power Association, and they hold registers of accredited training organizations. One that we know well in the UK is the NFPC. You can see the picture there on the right. And what we've seen over the years really makes a difference is the fact that this is competence-based training. This isn't a certificate for turning up. And so these are both hands-on and theoretical training. So both applied, as you can see those 3 people there working, and understanding the theory behind it with a test to actually check people's knowledge. Just perhaps a plug there for the NFPC. We sit on the advisory, but we don't get anything out of this plug. But I think they're an excellent institution. They also have a free assessment tool on their website. So if you have a team that are relatively inexperienced or have got a mixture of different levels of experience, and you want to put them through additional training, how do you know what training they've already had or what level they're at? There's a great free assessment tool on the NFPC site, which allows you to assess that. Okay, so first step. We can put a tick against, we can organise competence-based training, we can find the right providers, and say those providers are dotted around the world, and some of them even offer online training. So the second challenge for Steve is he doesn't have a structured maintenance program, and really he needs to develop a maintenance program for his company. Now, how might he do that? So here's a little example of one around the rock crusher, maintenance manual for mining and oilfield services. And what might that look like? So if we were to open that up, that tells you about the machine and a little bit about its details, its model number, etc., who's in charge of it, and then a maintenance log giving maintenance checks, frequency of service, whether that's daily, weekly, monthly, annually, and exactly what should be checked and what condition that's in. And then if you look a bit further into the maintenance manual, you'd expect to see a full circuit diagram of the hydraulics, so you can identify the parts, a bill of materials next to it, listing those parts. And then maybe for this example here, you can see a troubleshooting chart, which actually helps you diagnose a fault if something isn't working the way you think it should be. So some of you may be thinking, well, that'd be great, wouldn't it, if I had something that was that well documented? But what if I don't? This could be something you can request from the machinery manufacturer, or it may be something more bespoke that you need to create. And thinking of step one and the training schools, they're often a great place to find contacts or consultants to help advise on how you can develop a maintenance program. And I know, for example, the trainers at the NFPC have been frequently asked to almost reverse engineer a machine and its circuit in order to work out what is the circuit diagram and what training would be required to maintain it. So assuming that you've now grasped that and you have a program in front of you, a maintenance program in front of you, the maintenance you might want to carry out on it fits into different categories. That's what we want to look at next. So there's a machine that most of us will recognize, a car, and the maintenance on a car could also be described in a similar way. So we know that some components in our car are replaced when they fail. So it may be wiper blades or headlights. That's a relatively easy change, and we'd call that reactive maintenance. Other components are changed at manufacturers' recommended intervals, such as the engine oil or the cam belt. And that might be that every sort of 60,000 miles or 100,000 kilometers, you would go and change certain belts, or every time it's taken in for a service, you might be changing certain filters. And that we would call preventive maintenance. And then there might be other components on the car or other areas of the car where changing them isn't based on a set time period, but actually on how the car is driven and the conditions it's being driven under. And that might include things like brake pad wear and tire pressures, and there might be sensors actually fitted on the car which tell you what the status is of those two things, and then flag up when changes need to be made. And that we would put under the category of predictive maintenance. And then last but not least, there could be situations where you don't know whether they're ever going to happen, but you want to be prepared in case they do. And they would be looking at things like what happens if you have a flat tire. Carrying a spare wheel or using run flat tires would be a great way to get you out of that problem if that happens. And that we put under the category of proactive maintenance. Okay, so if we were to take those four areas, so reactive, preventive, predictive, and proactive, and just put them together as a little table, then we could look at them and say, well, okay, the reactive, I'm waiting for it to go wrong and then I'm going to fix it. Preventive, I'm estimating when it'll go wrong and I'll fix it before it does. Predictive, I'll monitor its condition and fix it when necessary. And proactive, I'll try to stop it going wrong, or I'll minimize the consequences of failure if it does. Why does that matter? Well, if you were to look at that in terms of efficient maintenance, you want to do as much planned maintenance as possible and as little kind of unplanned maintenance. That way you keep the cost down and the machinery running longer. So if we were to put a little logic tree together of those different maintenance approaches, so you can see at the top left there, proactive, can we stop it going wrong? Excellent. So like in the case of carrying a spare wheel, yes, in which case you're well on track for planned maintenance. If the answer is no, then we may be moving towards predictive maintenance. Can we monitor its condition? So in terms of the colors here, the difference between the blue and the yellow, if you like, is that the yellow really requires you doing condition monitoring, which typically means that you're going to be permanently installing some sensors on the machine. And that's not going to be the subject of the webinar today. We have done another webinar and may do another one shortly on condition monitoring. And that's a slightly different angle, if you like, on maintenance. Hence, we've put that in a different color. But the areas that we will be focusing on today is the other three types of maintenance. So after predictive, we're looking at preventive. Can we predict when it will fail? And really the last resort, if we can't do proactive, predictive or preventive maintenance, is then we're stuck with reactive maintenance. And then we've got to try and make that fault finding as efficient as possible. And we're left there doing troubleshooting. So one of the resources that we'll send out for you all tomorrow is a maintenance quiz that we set up about a year ago, where we asked people, how good is your hydraulic maintenance? And we asked them a number of questions in each of those 4 areas around proactive, predictive, preventive and reactive maintenance, and got back scores, if you like, from those people about how well prepared they are and how good they are in those different areas. So what do you think? What do you think would be the areas where people are good at maintenance and less good? Perhaps just ponder that for a moment before I put the results up on the screen. It perhaps not massively surprising, I put these results up, that the area where people are most comfortable is really around reactive and preventive maintenance. So 71% of people said that they're good at doing reactive maintenance, 74% said they're good at doing preventive, but really only half the people are saying that they're good at proactive maintenance, and only a third at predictive maintenance. And perhaps that's not massively surprising, but it does show where the areas are there for opportunities for improvement, if you like. So one of the parts of the questioning around how good are you at something was also around what tools do you have to carry out maintenance, and that's something we're going to focus on a little bit during this webinar, and what hydraulic tools and what hydraulic testing tools do you have in particular, which brings us on to the question, why would you monitor flow? For many people, their trusty diagnostic tool of choice would be a glycerine pressure gauge, and that's the answer to everything. And I guess this slide here is really about saying, is that really the answer to everything? So if we were just to fire up that pump, and it's running at 60 bar, and we've got oil going into that cylinder and lifting up that weight, we can see the weight lifts up in about 5 seconds, and we've got 100 litres per minute going into that cylinder. So if we put that same gauge onto the circuit of a pump which was only 50% efficient, and then ran that pump, we could see that it's still running at 60 bar, because essentially it's still got the same load it's got to lift. Otherwise the pipe work's identical, and the only difference is that the weight is taking about 10 seconds to lift rather than 5 seconds. So in terms of monitoring the pressure, that won't diagnose the fault for you. However, if you were to install a flow meter, monitoring the flow would. And there you can see an example of the RFIK. Okay, so let's just expand a bit on the different types of test equipment available. So here are 3 different ranges of testers that WebTech manufactures. So the top left, the RFIK, which is an all mechanical unit, literally no batteries in it, just uses the pressure drop to move a piston against a spring for measuring flow, has a thermometer, has a pressure gauge and a load valve. And then the DHT and DHM are both turbine-based testers with electronics in them, with a battery, and then different amounts of digital displays. The DHM is all digital, and the DHT is part digital, part analog. I think for this presentation, what's important to highlight is that when we talk about hydraulic tester, everything there can measure flow, everything can measure pressure and temperature. They all have a built-in load valve, and they all have what we call at WebTech interpass protection, and we'll come to that a bit more in a minute. So this webinar isn't going to say, oh, you must use this tester in this situation, or you must use that one in a different situation. Undoubtedly, some are slightly more suitable for some applications than others. They come in different flow sizes, but we're just going to refer to them all as testers. If we just expand slightly on the DHM, it also has the advantage that it's got some wireless connectivity. You can transfer results onto a phone, so you can do some basic data logging with it, and that gives you a bit more visualization of what's going on in a circuit. So they're the kind of what we would call portable hydraulic testers, all in one unit. And I guess what's significant about that is when you install them into a circuit, all the readings you're taking are in that same place, in that one circuit. You've got oil going through the unit, and you're measuring flow pressure and temperature in one place. Now, that may not always be suitable. There may be situations where you need to measure differential pressure, or you need to measure flows and pressures in different parts of the circuit simultaneously, in which case we would sort of advise people to go and look at the data logger ranges, which are the HPM range for us, and you can see some pictures of them there on the right. And then you can plug in multiple sensors, sort of up to 50 sensors, and then achieve all sorts of other analytics. Again, that's not going to be our focus for today, but they are the options, and you could still do flow measurement and loading systems with those as well. So perhaps the other thing just to reflect on is that we know that downtime is expensive. We know that Lauren is quite concerned about how much it's costing mining and oilfield services to run their fleet of machinery at the moment. And it's just worth reflecting on what is the cost of a breakdown. And we've got this little example here around this crushing machine. So the crushing machine stopped. It's full up of rocks. What do they do now? So let's call out a service engineer. It takes a service engineer about 4 hours to come out, about an hour to diagnose the fault, assuming they've got the right kit to do that. They then go, okay, perhaps the pump's failed. I need to order the new pump. So I've got to wait 12 hours for that to arrive. Got to fit and adjust it and commission the whole circuit. So that's about another 3 hours. Got to flush the system. It's another 4 hours. Recommission, clean up, total 26 hours of work in order to get that machine going again. Perhaps a conservative estimate on what the downtime cost is, about £2,600 an hour. So that's sort of about $4,000 an hour. Total downtime then, you work it all out with the cost of the pump and the shipping to get it there, you're heading very rapidly towards about $100,000, about £75,000. So when we think about downtime, it's not just the £7,000 for the pump or the couple of hours for the service engineer to actually fit something. It's all of the time. It's all the elapsed time while that machine is out of service. And to put that into kind of a bigger picture, there's some data from the Fortune 500 manufacturing firms, and as you see, the numbers are quite horrific, really. Okay, so we've covered the first 2 steps. So talking about building a team with the skills and competence in hydraulic maintenance, about developing a machinery maintenance program and the tools that you might want to have available to do that. And we've touched on the 4 different areas of maintenance. So really step 3 is about implementing that. So how do we carry out regular proactive, preventive and reactive maintenance? It's about opening up the cover now and getting inside. So if we look at it from Steve's point of view, say he's ticked off the first 2, he's on to the proactive part now of the maintenance. And so from Steve's point of view, he's asking, I need to ensure new tools are commissioned before use. And Steve's aware that every day they switch different hydraulic attachments between different excavators, and he's never seen any setup procedure for them. I think there's an assumption maybe by some of the operators that everything's interchangeable and it will just work. And proactive maintenance is trying to stop it going wrong or minimize the consequences of a failure. So if we were to look at a hydraulic breaker, and a breaker being used on an excavator, it's important to set up the flow, pressure and back pressure on the breaker attachment before you start using it. It's going to lead to better reliability. It'll extend the lifespan of the breaker. It'll also reduce downtime and definitely will improve safety and save costs. If you avoid doing that, or don't do that for a new attachment on a new machine, then the chances are that you could also be invalidating warranty. Here we've got an example that the DHT could be used to set that up, and so that would just be put in line into the hoses at the end of the boom arm in order to check what the flows and pressures are being delivered by the excavator, because often the excavator is manufactured by a completely different manufacturer to the breaker. And that would also be true if you were setting up a screening attachment. It could also be applied equally if you are setting up an auger attachment. So another area for proactive maintenance would then be to be looking at pumps overall, so pump setup. And a lot of variable displacement axial piston pumps need some setup done to them in order to make sure that they're operating the right parameters for that circuit, for that machine. We know that if things are adjustable, there's a chance now that someone will have adjusted it. So there's a concern that Steve's got that some of the failures in the field may be down to operators actually tampering with some of the pumps in order to get that bit more work out of the machine. It works a bit harder, a bit faster if I just screw that relief out in a bit. And so one of the jobs from a point of view of the maintenance engineers is just to go around and check that, for example, here maximum flow limiter, load sense pressure and the pressure limiter have all been set up correctly. And again, DHT is shown piped in here, is a great tool to be able to do that. It would equally be true if in the instance where the pump has broken and needs to be replaced, the replacement pump won't necessarily have been preset for that particular machine. It may be that pump could be used on multiple machines and each one will have a different setting, and that setup won't be done until the pump is fitted onto the machine. And again, the tester is ideal place to help do that. You can see here the graphs of the different flow pressure curves in order to set up those difference limiters. Okay, so we've touched on the proactive side of maintenance. Let's talk a bit about the preventive side. And so Steve's thinking, I need to ensure existing machinery is checked regularly, and preventive testing is testing to estimate when it'll go wrong and fix it before it does. So if we were to look at a pump in operation, here we're trying to estimate the life of that pump, and clearly you can see from that graph there that if that's predictable, then you're likely to be changing at the ideal replacement point. But if the duty cycle on that pump means that it's unpredictable, you could be replacing it way too early, and then you've essentially thrown out a perfectly good pump way before it needed to be replaced. Or if you're too optimistic about the life of that pump, you could be waiting way too late, and you've overestimated the life of that pump. So from a preventive maintenance point of view, what you'd be aiming to do is to take tests over time. Let's say that time period shown there is 10 years. You'd be taking points every sort of 6 to 12 months along there to look at how the pump is performing compared with last time and compared with the manufacturer's specification. And that would give you some idea of where you are on that curve and give you an indication of really of what the life of that pump is. So an example of that could be on the crusher, that we've got the DHM here. It could be used to carry out periodic checks on critical components. Perhaps the DHM would be more suitable here because you can carry out some data logging on it. You can pass those results over to a mobile phone, and then you've got some history automatically stored, which you can then come back to and compare results from last time. If we were to look at a mobile drilling rig, the same could be true. You can carry out periodic pump condition checks. Again, there's a DHT shown there. If you didn't have automatic data logging, you've got your maintenance log. It might be that you're writing those results into the maintenance log, and then you've got them there to compare to next time. Okay, so we've covered proactive and we've covered preventive, and we're on to reactive testing. And this is perhaps the area which many people associate the most with hydraulic testing as a troubleshooting device. But as we pointed out, it can be used in other areas as well. And as we saw from the graphs earlier, many people thought they were very good at doing reactive testing, sort of troubleshooting, probably because that's the place where everybody starts, really. Before full maintenance programs came into place, it was all about fault finding. And so let's just look at some examples of fault finding. So Steve's take on this is I need to ensure breakdowns, if they do happen, are dealt with quickly. And so let's just take an example here, fault finding on a vehicle fan drive system. So this could be true of any hydraulic pump system. The fan drive, perhaps one of the smaller pump motor drives on the circuit, but the principle will be the same even if this was the main drive for an excavator. So here we're installing, in this case, the RFIK portable hydraulic tester in line. If we just think about how that's going to be used, so we just look at the hydraulic circuit for that. There's the tank and the pump, and we can see a relief valve teed off of that, and then we've put the RFIK after it. So what we know about pumps is that if you were to test them at low pressure, as you can see from that graph at the top there, the pump flow may appear correct. And then with the help of the load valve, you can restrict the flow, the pressure will start to go up, and then you can see how the PQ curve develops, if you like. So what's the flow as the pressure is increased? And the aim being that you'll see the volumetric efficiency deteriorate if the pump is worn, or might deteriorate much more quickly than if it was a new pump. Now, there is another problem with that circuit, as I suspect many of you have already spotted watching this, going, yeah, but how do you know that it's the pump that's leaking and that you haven't actually hit the cracking pressure on the relief valve, or the relief valve is leaking and you're losing some of the flow over the relief valve? And you're absolutely right, that would be a bit of a flaw in doing that test. So you couldn't necessarily distinguish between the flow loss that's going over the relief valve or the amount that's leaking inside the pump. And so the alternative would be to move the tester to the left and plumb it in straight on the pump output. The Interpass safety system, if you like, is burst disk protection, enables the flow meter to be mounted between the pump and the relief valve. Why is that? Well, the burst disk protection will prevent you from over pressurizing the tester. So it has a standard burst discs that are rated to 6,000 psi, 420 bar, and so you won't be able to exceed that, otherwise the burst discs will rupture. As the service engineer, you'll have to keep an eye on what is the rating of your relief valve and your pump and your hose, because they may be rated only to sort of 250 bar, in which case you've got to be aware of that when you're testing it, or change the burst discs for some lower pressure ones in order to make sure you don't exceed that. But there is a safety system there available, which will give you some protection, despite the fact that you're in the circuit, installed in the circuit before the relief valve. So if we were just to look, sort of open up the tester, if you like, and look at its own hydraulic circuit, so you can see there that from left to right, we've got the flow coming in, we've got a pressure gauge teed off it, with the oils going through the flow meter, got a pressure gauge, got a temperature gauge and a pressure gauge teed off, and then the oil goes through the load valve, and then in parallel with that, we've got a burst disc. The advantage of that is that as when that burst disc breaks, that's a sort of safety system, the oil is bypassed past the load valve at low pressure, and the oil stays inside the circuit. So it's safe and flexible solution. If we were to look at the DHT, so this is using the turbine flow meter based system rather than your mechanical tester. Very similar, if you like. So we're going through the flow meter. We've got a temperature gauge on the side. We've got a little shuttle valve there, so we always see the high pressure side, because bidirectional, the flow could be coming in either direction. And then again, we've got two burst discs there to bypass the load valve should it be over pressurized. From a point of view of bidirectional capability, that's clearly advantageous if you're plugging that into a closed circuit transmission and you've got oil going both directions, then you can test that. The other thing is that sometimes I've heard that technicians, when they're putting the tester into the circuit, aren't sure which way the oil is going to be going through the hose, and in that instance the DHT and the DHM are more flexible. If you were to put the RFIK, we call it a reversible tester rather than bidirectional, if you were to put that in the circuit and you actually put it in back to front, if you like, so the flow was coming right to left rather than left to right, it would just show 0 on the gauge, and it would essentially be allowing free flow in reverse, but it wouldn't be measuring it. And if you were to put it in the other way around, it would be showing the flow rate. If we just elaborate on the Interpass safety burst disc system, you can see in that little postcard in the picture there is an example of 2 of the burst discs and how they sort of explode, how they petal out. There's no parts lost inside the system, it all stays together. They're a calibrated disc, so don't ever substitute them for non-genuine parts or anything as like another solid disc of metal, otherwise it will render the safety system useless. And they just sit on that olive that's indicated there and allow the oil to pass internally. So if we just think about the loading valve, which incorporates this interpass system, we just look at this little example here. So the flow's coming in from the left. Just bear in mind that a loading valve is a restriction, and wherever you're creating a restriction. So here we're loading the system, we're restricting the flow through the tester. We can see the pressure's going up. We can see that because the efficiency of the pump goes down as the pressure increases. We can see the flow's dropped off a bit, but wherever you're creating a pressure drop, you're also generating heat. And if we were just to do the maths on that, multiply the flow by the pressure and divide by 600, we got the powered, in this case in kilowatts, 123 kilowatts, which is roughly equivalent to 14 degrees increase in temperature. It's not a problem, but it just highlights that testers, while you're loading them, you're imitating the system working at full system pressure, and it will raise the heat in the system, and you should do that for a finite amount of time. You wouldn't want to leave that like that for hours. Okay, let's get back to Steve's story then. So Steve's got 4 ticks there now. He's gone through competence-based training for his team. He's developed a maintenance program. He's now started implementing proactive, preventive, and reactive testing. And the great news is he's starting to see the results. Uptime's increasing, and he's mitigated that risk to their reputation, and seen the costs come down for operating the fleet of machinery. So where are Lauren and Steve now? So Steve's happy. Lauren's happy. He's happy to see costs are coming down and service levels are going up, and he hasn't had to buy new machinery. And Steve's very proud of his team because they've grown in confidence, all that investment in training, and they're seeing machinery uptime increasing. If that's of interest to people on the call today, if you want to find out a bit more about hydraulic test equipment, so there's a little snapshot from our website. You can see on the left there, they're under the category portable hydraulic testers. We do have a comparison chart, so you might be wondering why you'd use one tester over the other. There's a comparison chart there, and give you a bit more detail. If you wanted to find out how you would actually get hold of one of these testers, there's a button at the top there to find a distributor. We do have distributors all around the world, many of them with multiple branches, and they've got a lot of expertise themselves. They would be a good first point of call. Perhaps just to reflect on WebTech, while we have standard products there, we are proud of the fact that we do many custom specials. We call that our capability to do that, and the process behind doing that, Make It Blue. It's a 4-stage process, which we call begin, listen, upgrade, and engineer. Why is that important? Well, there may be people sitting here thinking, well, okay, but what happens in my situation needs to be a bit different. I've got a slightly unique application. For example, the testers that I've just shown you, they're rated up to sort of 200 US gallons, about 800 litres. But we have developed solutions for mining machinery up to 1,500 litres. Why have we done that? We did that because we make it blue. We did that because people came to us and said, I need something different. There's other companies have said, I need that, but I need to have my brand name on it. So whatever those questions are, we'd like to think that we can handle them, and we have an approach and a process for doing that. Okay, that brings us pretty much to the end of the presentation for today. If you want to find out more information, please go and visit webtech.com, or our website. We'll say on the website you can find a list of distributors. I think some of them are on the call today. I'm sure they'd like to hear from you. If you can't find who your local distributor is, feel free to email us on sales-uk@webtech.com, and we'll make sure the right people get your email. The quiz that I mentioned beforehand, that how good are people in different types of maintenance, then there's a free quiz you're very welcome to take if you scan that QR code. I think it'll also be in the email tomorrow of useful links, and have a look at that. Okay, right, I've been busy talking at the screen here and not actually watching the chat. So Emma, how are we doing? Has we got any questions come in at all?
We do, yes. So I'm going to start at the top and read my way through because they're all linked. So our first question is, how does the turbine flow meter work? How do I choose the right model? Question about lead times, and a question about online training, if we provide online training, and the maximum flow and pressure of these models. So I suppose if we group these together, we want to look at how the flow meter works and how do we identify which is the right model for the end user.
Okay. All right, let's start there then. So I do have a couple of slides in case I thought something like that might come up. So I'm just going to bring across a slide on turbine flow meters. So here's a section through a flow meter. So if you imagine you had it lying in front of you, and you sort of cut it in half along its length, you'd see the turbine there rotating on a shaft with a straightener on either side of it. And then you got a pickup just above it and a signal coming out from that. So if we were now to put some oil through that, you'd see that the turbine starts rotating, and broadly you get a signal proportional to the frequency of rotation. Clearly, if the flow goes up, the frequency of rotation goes up and the signal increases. And so that's very, very crudely how that works. We would also have some electronics and software built on top of the flow meter because the relationship isn't exactly linear, and you want to get a widest possible range of flow measurement out of your flow meter. So from the lowest flows up to the highest flows, it's what we call the turn down ratio, the ratio between one and the other. And to achieve that, we do some clever maths inside the conditioning circuit to make sure that you're getting an accurate result over the full flow range. So as you can imagine, this technology works very well in both directions. So if you imagine the flow was coming from right to left, the principle will be the same. It still rotates. So it's not like a piston on a spring, which might then act like a check valve. So that's how that bit works. What other question was there around that, Emma? So
another question was how does an end user choose which is the right model, and what's the maximum flow and pressure of the units?
Okay, so I do the second question perhaps first. So the units we showed, the RFIK, DHT, DHM. So the RFIK, we make units that are scaled to 30 litres up to 270 litres with a few models in between. So if you were doing, let's say, pump steering testing, you might only want a 30 or 60 litre unit. If you're testing small mobile machinery, small agricultural machinery, then 270 litre unit would be perfect. The DHTs are scaled, and DHMs, there's a 300 litre, a 400 litre and an 800 litre version. So to put that in imperial sort of 100 gallon and 200 gallon sizes, and they'd typically be used more widely in sort of construction and mining machinery, and generally take you up to sort of 60-ton excavators, I guess, without too much problem. And above that, as I mentioned in passing before, we have for some of the very large mining machinery developed units that go up to 1,500 litres, so 400 gallons per minute, where the turbine is separate, the load valve is separate, the readout is separate, and that's quite simply because they're ludicrously heavy. I think the whole thing weighs like 45 pounds or something, like 20 odd kilos. But yeah, so we have solutions for different things there. In terms of pressure rating, everything's rated to at least 6,000 psi, 420 bar, and then the larger units with the SAE threads are rated to 480 bar, 7,000 psi.
Thank you. So the last two questions are around lead time. So I suppose depends on our distributors.
Yeah, indeed. So if I just touch on one other thing, we did mention on the website we have a comparison chart. So there's all the kind of technical detail, if you like, for the different models. So that's linked on the website under the portable hydraulic tester section. So that would be one way of looking at it. If someone said to me, how do I choose which one? I typically cite three things. Okay, so you're looking at performance, you're looking at preference, and you're looking at price. So from terms of performance, you might be asking what's the maximum or most typical flow ranges that I'm measuring. That would allow you to work out which column you're working on there, and there might be more than one choice. That, for example, you're looking at 400 litres, you've got some choices there. You might need to think about whether bidirectional or reversible is important. There may be questions around accuracy. And for example, if some people doing testing on case drain, there may be a maximum pressure that case drain can see without you blowing up the seals on it. And so the pressure drop across the tester may be important. And basically the turbine flow meters have much lower pressure drop than the RFIK. Preference, what do you prefer? Do you prefer all analog? Do you prefer all digital? Do you prefer glycerin gauge with digital reading? So there's some personal preference there. And then lastly, price, the RFIK, kind of more the entry level units, and the DHM more of the high level units. But for exact price and delivery, yeah, absolutely talk to your local distributor. Many distributors, I would say, would have at least one of those models in stock at any one time. Some of the distributors will have all of them in stock, and so delivery should be pretty good, unless you're looking for sort of larger quantities, in which case, I mean, our manufacturing lead time is 8 weeks, but you typically wouldn't see that because it will be in stock somewhere.
Thank you, Martin. And we do have a question about, do we provide online training?
Depends what you mean by online training, I guess. So in terms of what we're doing now, clearly this is a sort of online training. So we offer a number of webinars for customers who, let's say, have invested in a large amount of test equipment and they want their team to be trained. Then that's something that our distributors can do. It's something we can support, and absolutely we can do training on that. If you're talking more generically, like how do you do hydraulic maintenance on systems, then we would look to the training schools, like I mentioned at the beginning, and you'd go to an NFPC or an equivalent in the US or elsewhere who are much better set up to be talking and teaching hydraulics and hydraulic maintenance broadly, and all of the basics behind it. And there is a site, just to mention, actually, there is a section on our website, an educational section, with a lot of those links on there as well.
Okay. And also we have the video on there for the changing the safety burst disc, so people.
Absolutely, yeah. There's a whole host of different videos. Some of the things that we've alluded to here, whether you're doing like a pump test or a T test, we have little videos. I think there's a video on there which we did with one of our customers on how to set up an attachment and a breaker, and it actually shows that as in real time on site how a breaker would be set up.
Okay, we do have a couple more questions. So we have a question to say, if we've got an older model, can it be updated? I think that depends on perhaps what the model is.
Yeah, indeed. So we do have 5, soon to be 6 service centres around the world. So one in each of the WebTech locations in the UK, Germany and America. And they're your best point of contact if you're close to those. We also have one through our distributors Talleres Lucas in Chile that would cover sort of Southern South America, one with Stauf in Australia, and soon to be another one in India through HTM Hydraulics. They all are authorised WebTech service centres, and they can all offer support and answers to maintenance questions on test equipment. So whether that's how do I get it recalibrated, or can I have annual maintenance on it, or can I have it upgraded, they're your best port of call. But as you might appreciate, that the answer to that will depend on the age and model number of the tester that you've got.
This next question, I think you've answered it. It says, is there a service required for an older tester? I don't know if that's asking what the service requirements are, calibration.
Yeah, someone else on the call might be, and perhaps you know the answer to this, Emma. I think we recommend 12 to 24 months typically.
Yeah, once a year for calibration, and that includes a functionality check and any advisories. I think it's just once a year. Steve on the call today. Do we have an hours? No.
Top of my head, I've got the feeling we might say 4,000 hours or every 12 months. But interestingly, the new range of DHTs does have a reminder system built into it, just to remind you, how long it was since it was last calibrated, a little clock that will tell you when your next calibration is due. And so, there's another tool there to help remind you to keep everything sort of well maintained.
Okay, so I don't see any more questions Oh, what was this one? Is the service with WebTech Direct or via distribution? So I know you just spoke about the service centres, but perhaps if we can just mention those again.
That varies a little bit by country. So if you're already buying from your distributor, then speak to your distributor. Say it varies by country. We have different, slightly different models.
Okay. If you aren't already buying through a distributor and you have questions about service, feel free to use the email address that Martin had on a previous slide, which is sales-uk@webtech.com. Thank you, Martin. And you can forward your questions there and we'll make sure they get directed to the right person, whether that be WebTech in the US, in Germany, or one of your distributors. Does anybody else have any more questions? Feel free to unmute yourself if you'd like to ask your question in person. No, I think that may be it, Martin.
Okay, excellent. I just see the clock's nearly counting up to 60 minutes. So I appreciate everybody's time today. It's been excellent to have so many people join and ask so many questions. Thank you, Emma, for facilitating today's webinar. Is there anything else that you'd like to add, Emma?
I'd just like to say thank you again, and thank you, Martin. It's very interesting, lots of information there, and nicely put with the story. We'd like to say thank you to everybody attending this afternoon, evening, morning. I don't know what time it is from where you're joining. You will shortly receive the recording of today's webinar. I'm going to send it out as soon as it comes through, and it will land in your inbox with the email that you used to register for this webinar. Then tomorrow, you will receive an email with a feedback survey and information about past and future webinars, and I believe there'll be some useful information following on from today's presentation. So again, thank you very much, and hope to see lots of you at the next one.
Brilliant. Thanks, everybody. Goodbye.
Bye.
Thank you. Thank you.
Bye. Bye. Bye.
Bye bye.
Thank you.